All right, you made it. Part 4 of the factoring mini-series, right? So, we have 3 problems here. I'll try to go through them relatively quickly. But the difference between these 3 problems and the problems from the last set of problems we did in the last video, hopefully, the thing that you notice first is that all of these problems have just 3 terms. In the last video, we learned a method called factoring by grouping, where we take our 4 terms in our polynomial and we separate them into groups of 2 so that we can factor out something very quickly. In these cases, unfortunately, well, let's look at number 12, right? So number 12, just like the other 3, there's only 3 terms. So it wouldn't really make sense to try to group them into 2 sets of 2 because you can't really factor something. I mean, you can factor something out of 1 term. It's just not very helpful, right? So what do we do? Well, if there was a way to where we could take something that is made up of 3 terms and compose it of 4 terms, that would be pretty helpful. Here, I'll use a version that's not already written on, right? So let's look at number 11 again, right? So number 11 is one that we solved for. We know that we can break this one into negative 4x plus 5 and plus 3 times x plus 5. I'm sorry, yes. Negative 4x and then x plus 5 plus 3 and x plus 5. Then we factored out the x plus 5. And then we left with a negative 4x plus 3. But if you notice, if we had just approached this problem like any other algebra arithmetic problem, the first thing we probably would have tried to do is simplify those 2 terms. We have negative 20x plus 3x. So, I mean, we could totally sit here and be like, all right, well, what's the sum of negative 20x plus 3x? We could rewrite this as negative 4x squared minus 17x plus 15. Except that wouldn't really help us because now we have a problem that looks like all of these. And we're trying to go the other way. We're sort of unsimplifying, if you will. So let's see what we can do. Is there a way to rewrite a term or an expression with 3 terms as with 4? Well, yeah, obviously. We just saw how we can take negative 20x plus 3 to get negative 17x. Who's to say we can't take negative 17x to get 20x plus 3? Well, that's all well and good, but how would we know to do 20x plus 3? Well, here's how, right? So it's not really a trick, but this is the method that you use. So we want to be able to separate the middle term into 2 terms that add up to the term we started with, but just any 2 terms won't do. They've got to be something that have common multiples with both this term out here and this term over here. That way we can factor it. So what we do first is we take what we call the A, right here, and the C value for this quadratic expression, right? You know, ax squared plus bx plus c. So there's a and there's c. And we will multiply them together. So negative 4x plus 15. Well, that gives us negative 60. All right, so now we need to find 2 terms that multiply to give us negative 60, but also add up to negative 17x, because we just saw they need to be able to add up to negative 17x. Well, lo and behold, if it's not obvious immediately, you can start listing them. You know, there's 1 and negative 60, of course. We know the number has got to be negative, so we'll make the negative a bigger number. There's 2 and negative 30. That would give us not negative 17. Oh, look, 3 and negative 20. 3 and negative 20. We could rewrite negative 17x with 3 and negative 20, and we would get something that we can eventually factor. And that's exactly what we did with this one. We factored out the negative 4x and the 3, and it went from there. So we can employ that same method on 12, 13, and 14. And it works just the same. So on number 12, let's say, all right, well, I have 11x in the middle, and my a value is a 3, and my c value is a 10. Now again, unlike with number 11, we don't know where the end is, so we can't cheat, really. So we'll just go ahead and multiply our a times our c. 3 times 10 is 30. And now we need to come up with two terms that multiply to give us 30, but add up to give us 11. Well, we find the multiples of 30. Well, there's 1 and 30. That's 31. That doesn't really help. There's 2 and 15. No, that doesn't really help either. There's 3 and 10. No, getting closer. That's 13. Well, what about 4 doesn't work. 5 and 6. That adds up. That multiplies to 30. Oh, look. That also adds up to 11. 5 times 6 is 30. 5 plus 6 is 11. So we can rewrite 11x as 5x plus 6x. Just like we could rewrite negative 20x plus 3x as negative 17x. We can go the other way. So let's do that. I'll rewrite this whole expression, 3x squared plus 5x plus 6x plus 10. Now, maybe the immediate burning question is, does it matter whether we write the 6x or the 5x first? The short answer is no. It doesn't really matter. So from here, we can now use the method that we used in all the previous problems. Because look, it looks like all of the previous two problems from the last video. So I'll put it in my two groups. In parentheses. I'll see what I can factor out of the first binomial. We have 3x squared and 5x. Well, they don't have a number in common, but they do both have an x. So I'll factor out an x. That would leave me with 3x plus 5. And then over here, well, they don't both have an x, but both of these are divisible by 2. So let's factor out a 2, and that would leave me with, well, 6x divided by 2 is 3x, and then 10 divided by 2 is 5. And look, it worked. Now we have one term and another term where the binomial is a common factor. So we can factor out that common binomial just like we did back in video 2, and we'd be left with x plus 2 would be our leftovers, and then 3x plus 5 would be the binomial that we factored out. So I know I went a little bit fast, so if you need to rewind the video and rewatch that, feel free. But at this point, again, pause the video. Try to do number 13 and 14. I know I didn't leave very much room on here, and I apologize. I'm trying to write big so you can see. Pause the video. See if you can employ the same method we did on 12 to 13 and 14. They're all positive terms, so I did that on purpose, right? So give them a shot. All right, so number 13 is a bit easier. You see that two numbers that multiply, they give you, well, so we multiply our a and our c, we get 10. So we need two numbers that multiply to 10 and give us 7. Well, that happens to be 2 and 5. So we can separate this whole 3-term polynomial into a 4-term polynomial where the 7x can be written as 2x plus 5x. And now we have our a term here, 2x squared, and then our c term over here, 5. So again, all I've done is I've taken this and I've rewritten it using 2 and 5 because 2 plus 5 is 7. So now we can group them. 2x squared plus 2x, well, the common factor on that one's pretty easy. They both are divisible by 2x. After we factor that out, we'd be left with an x and then plus 1. 2x divided by 2x is 1. And then here, 5x plus 5, well, they're both divisible by 5. So that would leave me with x plus 1, just like in the previous problem. So again, I have a common binomial, so I can factor that out. And I'd be left with 2x plus 5. Oops, I did not write that very well. I promise that's a 5. You gotta believe me. All right, last one. You see on this one, I made my little t-chart a little bit longer. Two numbers that multiply to give me 60, which is what 5 and 12 multiply to, but add up to give me 19. 19 is a bit of a weird number. It's prime numbers. Maybe it's not obvious, so you just keep listing them. I did 1 and 60, 2 and 30, 3 and 20, 4 and 15. Oh, Those add up to 19. So now I can rewrite, oops, draw my pencil. Now we can rewrite this as 5x squared, and now instead of plus 19x, we'll say plus 15x plus 4, because those add up to 19x, but also multiply to 60, plus 12. Sorry, 4x. My mistake. Don't hate me. So, two groups, just like previous. Factor out the greatest common factor. 5x. 5x squared divided by 5x would just be x. 15x divided by 5x would just be 3. Now our second one, 4 and 12, greatest common factor they have in common, well, 4. So I divide 4x by 4 and I get x. I divide 12 by 4 and I get 3. And now we have it very easy. So factor out the x plus 3. And we'd be left, we'd be left with the 5x plus 4. And there you have it. That is essentially factoring by grouping in a nutshell. I'm sorry it took 4 videos. It's a long process. If you don't remember, I know this is taught a little bit in Algebra 1, maybe a bit in geometry. But if you haven't had it in a while, hopefully this 4-part series is able to take it all the way from I know nothing to I know everything. I hope it was helpful. Again, just as always, if you have any questions, leave them in the comments, and I'll see you in class.